To solve the first problem, we can just directly look through this assembly code. From the first line, we can see that EDX is a 4 bytes register, and it has been initialized to 0. So we know that EDX is an integer. And then we compare, and we move EDX to R8. This implies that R8 is also an integer. And then we do some calculations on RDI and store it to RCX. Since here it says it's Q, this means 8 bytes. So we know that RCX is 8 bytes data. Here we evaluate the data stored at the location of RCX, and from here we know that this one is 2 bytes. So we now know that RCX is a pointer pointing to a short. So then we can know that this one is also a short pointer, which also implies that RDI is a short pointer. So this question should be short star. Okay. So for the second argument, from here we can directly know that this one is also an integer because here is L. And EISI is also the lower 4 bytes of the register RSI, and RSI should be the second argument. So this one is an integer. And since the assembly code doesn't really modify RAX, so this function returns nothing. So here should be void. And then we just write it down. And because EDX is 4 bytes, so it is an integer. And then from here we know that it is initialized to 0. So for part D, we can look at this assembly code line by line. And from here we can see that these 3 lines. So we ignore R8. We ignore R8 because it is just a temporary registers compiler used to simplify calculation. So these 3 lines just means that star RCX equals to 3 star RCX. And then from these 2 lines we know that RCX is equals to RDI plus 2 times EDX. And because EDX increases by 3 each iteration, so we can conclude that this function is basically just triples the number in the array RDI, whose index is multiples of 3. So if if a short array looks like this, and then the final output, the final array stored in the RDI should be 3, 2, 3, 12, 5, 6, triples these 2 positions. And that's it. Thank you.